welcome to the channel. I sent data over several miles using these two nodes, and this sending node and receiving node, and you can see the data receiving on this side, and you can actually see that there's some data arriving there. So I did this using LoRa chips. This is not Meshtastic or Mesh Core. This is a level lower than that. So sometimes you just need to send some data and you want to send it from one piece to another. And then you can build something like this without, the LoraWAN, or without, Wi-Fi or cell phone networks. You just want to transmit some data. Small amount of data, very far. And this is what this little experiment did here. Let's show you how it works. So inside of these units is the latest chips from REYAX, and it's a RYLR999 chips. And what makes these specifically very interesting is that they have both Bluetooth and LoRa 915 built in. And you can set the frequency, of course, but from the LoRa side, you can send data miles away, and then it also has Bluetooth, so you can read the data with a Bluetooth device, like my cell phone over here. So this becomes the UI that for it. So the LoRa is 30 dBm power, and 1 watt power, and it can do long range. And of course, what's also interesting about these these new chips is that they have this little IPX connectors there, so you can actually properly mount antennas. The previous versions had a little built-in antenna. Now you can actually put a real antenna on there. So you can see I've got a 915 antenna and a 2.4 gigahertz Bluetooth antenna, both on each one of these chips, which is really cool. And there's separate UARTs. There's one for Bluetooth and there's one for LoRa. And you can actually bridge them. If you see over here, you can bridge them to send the data essentially from Bluetooth, bridge it over to LoRa, send it over LoRa, miles away, take it out of LoRa, bridge it back to Bluetooth. So you could do something like that, which is really, really cool. Okay, if you wanted to measure a real world use case, would be something like, let's look at water levels or something like that. And so you could, on one sensor, this is this receiving node, here's the sending node. So you could send data miles away and read it on a Bluetooth device, which is really, really cool. In agriculture and livestock and emergency off-grid and, city and infrastructure, and of course DIY builders like ourselves can use this. So how I went about this is, of course, just having these chips lie around, just on a bench is pretty annoying. So I actually printed these 3D cases with 2 holes at the top for the antennas, and I could mount the chip inside there. Now it's it's sort of secured, and then I print a little cover and I made a hole at the bottom where it receives power from, right? So that was the first thing that I did. And then I connected the chip directly to my PC using USB to serial. And I could send commands like AT reset, and I would reset the chip, or I would send AT address, I would give it the address, or I would send data like hello, and that all worked. But then I added the Bluetooth jumpers, and now when I sent the data, it actually ended up on Bluetooth. So, I would send in hello, it would go into the chip from my PC, it would travel over LoRa miles away, and then on the other side it would come into this receiving node, and it would actually come out onto Bluetooth and into the mobile app. Like you can see there, I am receiving data there at the moment that says, you know, message 48, 47, 48, and I think, you know, so I'm actually at the moment sending a message every 10 seconds, so there's message 49. So how I did that is I connected these ESP32C3s, and the only reason I did that is, you know, so that I can actually do a little test. So the send node, which is the one on the left, actually I wrote a little CircuitPython application on there, and the source and all that will be available in the project. But all that it does is it every 10 seconds sends in this message, which says message colon 52, message colon 51. So every 10 seconds it sends out another message, and we'll wait for the next one. That was 52, there comes 53. So every 10 seconds this little ESP32C3 here sends data, and then it's received by this side, this LoRa chip, and then it's bridged with these jumpers onto Bluetooth, and then I can see it on my phone. And on my phone I have this app, the app that I use here. It is called, and let me get the name of it. The app is actually called, so I'll go through it. It's called Light Blue. So what I do here is, there we can see the actual REYAX chips. I can connect to them, like I can connect to that guy via Bluetooth LE. And then I'll go into my character set 2, and I'll subscribe to the messages received. We can see that there was message 59, and now that I subscribed, I also changed it to print it out in UTF-8 string over here. So there we're starting, there's message 60 has just arrived. So as this one generates the messages, sends it over LoRa, this one receives it via LoRa, bridges it over to Bluetooth, and I can view it in the app. How about that? That's pretty cool. So, and to power this, I'm just using, power banks. So there's 2 power banks here, one for each. And of course you could have built-in batteries, and you can have solar, and there's the whole array of things you can do. Actually, on this one, you know, I've got ESP32C3 in there, but you can see there's only 2 wires coming from it. I'm really just using the 5 volt there. This side, on the Bluetooth, where I read the Bluetooth, I really don't even use the, any features. The only reason I have it in there is to provide 5 volts. And that is important. These chips do not work on 3.3 volts, they work on 5 volts. So it's important to remember that. So they've got the 5 volts this side. This side you can see I've got the 5 volts, and I've got the TX and RX lines, so that it and I've connected that to pins on the ESP32C3, so that I can generate a message. And that message then, like I said, gets sent over LoRa, then to Bluetooth, then to the app. And that's pretty neat. So I did some tests out at the Fort DeSoto. Me and my wife went there, and we wanted to see how far, this would go. How far would these sensors actually go, how far the data would travel. So let's have a look at that, let's go through that step or that footage, and I'll show you how it actually works. Okay, we're at the Pier, and got the send node there, got the receive node here, and the Bluetooth app, and we're receiving messages. Let's go. So we're at the end of a pier, we're still receiving messages. I left it message 10, it's now message 30. So it just keeps going. But how long is this pier? Let's find out. How long is the pier at Fort DeSoto? Let's see. One mile? What? 1 mile. 1,000 feet. Oh, okay. 1,000 feet. That's quite a bit. Okay. 5 along. There's a shorter one, yeah. But to message 40, I'm now in the parking lot. The pier is way out there. So way down there. So let's go for a little ride. Yeah, I'm at message 42. Messages. And the antenna is just lying next to me over here. Receiving messages. Right, I'm way out here now by the Skyway Bridge in the distance there. Just way on the other side. I am receiving some error packets, but I did receive at least one message over here. You can see I'm carrying the node in my hand now out on the beach here, but I did receive a message out here. So let's go to the other side. Right, I'm now at the top beach, and I started receiving messages again. We're at 142 at the moment. I'm just gonna walk out here a little bit from behind, you know, the trees and bushes and stuff. But I'm way up at the North Beach. Right, way at the North Beach. You can see I'm reliably 153, 54, 55, 56, 156. And way out here, the is that way. I think the pier where the other unit is way out there, but it's reliably receiving them 157. So, and also keep in mind, you know, this is with a standard antenna. This isn't a special antenna or anything. So we're at 159, and we're probably going to receive a next packet. There it comes, 170. It's minus 72 and minus 3 at the moment. That's RSSI and SNR, signal to noise ratio. But it definitely, this is far from where the sending unit is. Also beautiful. It's just turning spring here, so. Right, I'm at the closer beach now. Actually at the fort at Fort DeSoto. So let's take a walk through there. At the moment, you can see I'm reliably getting 207, 208, 209, 210 just arrived. Let's just take a walk through Fort DeSoto. 218, there's the cannons at Fort DeSoto. But this is 218 over here, the 219 just arrived. Let's actually test this while we're here, just by going into these bunkers. I'm going to go into one of these bunkers at Fort DeSoto and see what happens. We're at 220. Ooh, this is scary. 220. Nope. I doubt it will work inside here. This is way too scary. You see, it gives an error 12, so it couldn't decode the message. But it did receive something inside there. Woo! Woo! Now I'm back. Just got across the parking lot, onto the pier, and I'll be at the source. We're at 229 packet. Receiver node's doing good. 230 just arrived. We're about half a mile to a mile from the source. So we can see the RSSI is getting much better. And I've only got to walk the pier now. And we're back at 242. Every 10 seconds a packet is sent. There's 243. We can see that the RSSI is pretty good. Heading down the pier. There we go. We found the source. You good? And there is the source. Good job. Thank you. So hopefully that was interesting. If you've got any questions, please let me know. As usual, the links are in the description. And if you got any questions or want to play with something and try something with this, let me know, and we can maybe work together and get it done. Go have a look at LoraMeshDevices.com or hub.LoraMeshDevices.com. That's where the project files are with all the source code, and everything I did here is available there. So thank you.